Today we are going to learn chapter 34, Guyton and Hall, physiology. The chapter name is resistance of body to the infection. In this chapter, this is the first part of an inflammation and the immune system. The second chapter is the chapter 35 is the second part of this same thing. In this first part, we are going to look at leukocytes, granulocytes, monocyte and macrophage system, also called as reticuloendothelial system, and the inflammation, some inflammatory reactions. What our bodies on the daily basis is exposed to various kinds of pathogens like bacteria, viruses, fungi, parasite, and which occur normally in varying degree of in the skin, our openings, urethral openings, vaginal openings, and mouth, respiratory, also nasal openings, intestinal tract, lining of the some cell membranes, tissues. And to combat these kinds of viruses, or we can say in a collective pathogens or bacteria, our body has developed some systems in which the WBC and the immune system. These WBCs do the function of phagocytosis, while the antibodies are produced by the immune system to combat with these viruses. In this chapter, we are going to look at the phagocytosis primarily. In phagocytosis, WBCs are the main players. In that, what are the WBCs is just a basic idea of about the WBCs. WBCs also called as the white blood cells or leukocytes. They are mainly produced in the bone marrow. In the bone marrow, also granulocytes and monocytes with only few lymphocytes are produced in the bone marrow. So primarily, granulocytes and monocytes are the leukocytes which are mainly produced in bone marrow, while the other kind of leukocyte, that is the lymphocytes and plasma cells, are produced in the some other tissues of the body, like lymph tissues of the body, including liver, spleen, lymphoid organs like you can say lymph nodes also. And after they form, they are transported to the blood, where to the different parts of the bodies where they are needed for their function. Most of the WBCs are specifically transported to the location or that specific tissue where the inflammation is going on, or if the inflammation is not there, these WBCs will be stored as a reserve when the inflammation will come or the stimulus will be given. The granulocytes and monocytes have a special kind of ability, that is the seek out and destroy, means they can identify the pathogen right then and there and destroy it then and there only. That pathogen is like foreign invader, it's mentioned here as the foreign invader, that's fine. Then general characteristics of the leukocyte. In that, first we are looking at the types. There are total 6 types of the leukocytes. First one is the eosinophil, basophil, and neutrophil. In that, neutrophil is the abundant. Then the fourth type is the monocyte and lymphocyte, and occasionally we consider plasma cell as the type of leukocyte only. In that, there is another type of cell or the thing in our blood that is called as platelets, which also helps in the inflammation and clotting kind of thing, blood clotting things. But it is derived from the other type of stem cells rather than the leukocytic stem cells, which is the leukocyte, or the the cell which develops the platelets is called as the megakaryocytes. And the first type of cell is the polymorphonuclear. First type of cells means these eosinophils, basophils, and the neutrophils. They are polymorphonuclear. Poly means many, morphology. Morpho means their their appearance, and nuclear means their nucleus appears as a many nucleus. Means there is an only one nucleus, but they have various lobes in there. Like neutrophil have 3 lobes, so it is termed as the polymorphonuclear. And these 3 cells, that is eosinophil, basophil, and neutrophil, contains granules which contains digestive enzymes, which acts as sometimes as a lysosomal enzyme. In the case of eosinophil, are called as the granulocytes. The classification is like granulocytes, which contains neutrophil, basophil, and eosinophil. Then monocytes and lymphocytes. Okay. Then the granulocytes and monocytes protects our body mainly from invading organism and ingesting them, and by releasing some antibacterial or anti-inflammatory substances which will kill the organism. The lymphocytes and plasma cells mainly function with the immune system, which we will see in this next chapter. Like there are some B lymphocytes and T lymphocytes, the types of lymphocytes, and then plasma cells are there, which also helps in destruction of pathogen, that we will see in next chapter. Platelet is mainly for blood clotting, where if there is a cut or something, platelet will go with the help of fibrinogen and fibronectin, other clotting substances. It will form a clot so that bleeding won't happen. Then there are different concentrations of white blood cells in our body, that is 7,000 WBCs per microliter. The hemocrit, I'll like to tell you what is hemocrit. Hemocrit is the amount of blood derived from testing. Like 1 microliter is called as the hemocritic volume or the hemocrit volume. In that 1 microliter, 7,000 WBCs are present, which is then 100% of WBCs. And from that 7,000, 4 to 5,000, which is nearly about 62% of the neutrophils are present in that WBC, while leukocytes are 30%. This is the second major. Then monocyte, that's 5.3, and the eosinophil, that is 2.3, and then lastly, which is the least present, is the basophils. The number of platelets is between the 150,000 to 400,000, 450,000, which averages about 300,000. Why we are talking about platelets, but when it is not from the same origin? Because in this chapter we are going to look at some inflammatory reactions. So in the next chapter in more detail, we are just going to have a basic about it in this chapter. That's why we need to learn platelets. So just remember that there are 300,000 platelets in our body in 1 microliter of blood. Then leukopoiesis, genesis of the white blood cells. All these white blood cells are derived from a multipotent hematopoietic stem cells. What is a multipotent hematopoietic stem cells? Which is a leukocyte, here it is mentioned in myelocytic lineage, and there is myoblast. And in the right side, that is the lymphocytic lineage, is the lymphoblast. Here it comes. There is a common cell on this, that is called as the hemocytoblast. From in this hemocytoblast, there will be two divisions, that is the myelocyte and lymphocytes. These myelocytes are the mother cells of the three types of blood cell: RBCs, WBCs, and platelets. And lymphocytes are specifically for the B lymphocytes and T lymphocytes. In that, this is the erythropoiesis, let's say. This is the platelet formation, and this is the WBC formation, for example, just now. But here it is shown as the complete WBC or WBC formation only. I'm just giving example. So coming back to the main point, the leukocyte is derived from this myeloblast or myelocyte. The leukocyte will form then granulocytes, eosinophil, basophil, and neutrophil, and monocytes. But lymphocyte will be derived from this lymphocyte, and the platelets have their own megakaryocyte, and the platelet will be formed here. Then these granulocytes and monocytes are formed only in the bone marrow. We discussed it already. And these lymphocytes and platelets, plasma cells, are formed mainly in the lymphogenous tissues like lymph nodes, lymph glands, spleen, thymus, tonsils, and pockets of lymphoid tissues. And pairs passage mainly, bone marrow and pairs patches mainly in the underneath of the gut walls of the epithelium of the gut. The WBCs are stored in the marrow until they are needed for their function, but uh, and they are stored in the bone marrow mainly. And our bone marrow contains about 3 times more WBCs than there in the circulation. That means if there is a 1 WBC in the circulation, there will be 3 WBC in the bone marrow. Bone marrow will contain the 3 WBCs. That means we have a total 6 days of supply of the total WBCs. Then this lymphocytes, we talked about WBCs, in that mainly granulocytes and monocytes. Now the lymphocytes, which are stored mainly in the lymphoid tissues, except the small members, are stored in the blood, temporarily in the blood. After they'll travel and used in the lymphocytic or inflammatory reactions. And then this megakaryocyte, which is the precursor or mother cell of the platelet, is also formed in bone marrow. And the small fragments are known as the platelets, like the derived from the megakaryocyte. The small fragments of these megakaryocytes are known as the platelets, and then they pass in the blood and do the function of clotting. What is the lifespan of blood cells? Means white blood cells, specifically talking here. In that, the first group, granulocytes have a lifespan of normally between 4 to 8 hours in the circulating blood. And when they reach their targeted tissue, they have a lifespan of about 4 to 5 another 4 to 5 days in that tissue. given that they do not involve in any kind of phagocytic function. And then the next type of cell is the monocyte. Monocyte have a short transit time, but they have a longer retention time in the tissues compared to the granulocytes. Like monocytes take 10 to 20 hours in the circulating blood. It's obviously more than that of the granulocyte, but comparing the lifespan of monocyte with the granulocyte, it's way low. Then these monocytes travel 10 to 20 hours in the tissue, in the circulating blood. Then they go to the tissues and get and they become swollen, and they increase in the size and shape, and they are now called as the tissue macrophages. When they reach the tissue, they still need uh, about 8 hours to become mature and turn into a tissue macrophages. These macrophages are the basis of the tissue macrophage system, and this tissue macrophage system is also called as the monocyte macrophage system or the reticular endothelial system, which we see in this later in this chapter only. Then lymphocytes enter the circulatory system continuously because we need them for pathogen, because there are many more pathogens in our body. From these various openings, they are coming continuously. How they are travel in our body is that, let's say this is an blood, or the, we can say like a drainage of lymph. From this lymph drainage, they goes to the tissue, they do their function, they will again go to this lymph drainage, then they'll transport it to the blood. From blood, they'll come again to this blood supply, or this blood flow, and then they'll again go to the tissue. This is the complete cycle. And this lymphocytes going out of this blood vessel or the capillary is by the process of diapedesis or extravasation. We will know in detail or more depth about these processes like diapedesis and extravasation in later chapter. This is just introduction about the full chapter. Then lymphocytes have a lifespan of about span of weeks or some months, depends on the body for the cells. Like for example, for monocyte and granulocyte depends on the phagocytosis. For lymphocyte depends on the antibody reactions. And platelets are the blood clotting substances, which have sadly a lifespan of 10 days only. They are getting replaced. And by the way, they are replacing at the speed of 30,000 platelets each day for each microliter of blood. Each microliter of blood. That's it. This is not that important, but it's good to know that neutrophils and macrophage defend against the infections. You can say here neutrophil macrophage system for the defense against the infection, or the, you can give name as the neutrophil macrophage system. It is mainly the neutrophil and the macrophages which are involved in the killing of the pathogens. Neutrophils are the mature cells, monocytes are the immature cells in the circulating blood. That's why neutrophil can kill the pathogens right then and there in the blood itself, because they are matured. And macrophages begin their lifespan as the monocytes in the as the blood monocytes, which are immature cell and in still in the blood. But when they get mature, they gain ability to digest a larger size of bacteria or pathogens, which is like 5 times more larger than their shape maybe. And these are cells are now called as the macrophages. When they develop from monocyte to tissue macrophage, or we can say directly the macrophage, this developed cell, this increase in shape cell called as the macrophage, now it is extremely capable of combating diseases against the tissues. Then how do they do, what is the complete process step by step? Now just look at, this is the first step. White blood cells enter the tissue spaces by the diapedesis. It's obvious, yeah. Let's say this is an capillary, and these WBCs are flowing continuously through this capillary, and there are membrane or the gaps between the endothelial lining. There are some molecules or proteins present on this endothelial lining, which helps these WBCs to go and do the process by go to the tissues or the inflamed tissues by the process of diapedesis. What is diapedesis? Diapedesis is the squeezing of WBC or blood cells through the spaces between the endothelial lining and reaching or responding to the chemotactic responses of the or chemotactic uh, products of the inflamed tissue. Then this white blood cells moves through the tissue spaces, because I know this is now out of the capillary, but it's not like it is only one tissue. There are many more tissues to go and perform their function, or maybe get stored there as a tissue macrophages. For going there, this white blood cells moves by amoeboid motion. What is an amoeboid motion? Amoeboid motion is simple. Let's say this is an WBC, or this is an WBC, in which this is it is filled with the cytoplasm. When they have to move like amoeboid motion, they'll send their cytoplasm little bit here, little bit here, little bit here. They'll form like this is an WBC. They'll send their cytoplasm here, 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 and they'll form like false leg kind of structure, but they are not leg, they are just extensions of WBCs, and they'll crawl like this and will and this is known as the amoeboid motion, and will go to the specific tissue where they has to get stored. Their velocity of movement is as much as their own length per minute. Let's say the normal size of an WBC is 60 to 80 micrometers. It's 40 micrometers per minute, and this 40 micrometers. Let's say this is where the WBC is. Now, after a minute, this WBC will travel the next 40 micrometers, and then next 40 micrometers. It is 40 micrometers per minute. That's it. Then WBCs are attracted to the inflamed tissue by the tissue areas by the chemotaxis. As I told you earlier, there are chemotactic substances produced by the inflamed tissue or the tissue surrounding the injured tissues. These neutrophils and macrophages move toward the source of these chemicals, and it is known as this process or this phenomenon. Now it is known as the chemotaxis. Chemotaxis is, in simple word, is you got some signals and you are going towards that signals, is known as the chemotaxis in the cells. In the cells, these signals, what are those signals? These signals are or these substances that are produced by the inflamed cells are bacterial or viral toxin, which bacteria and viruses will secrete at the inflammation site, at the site of inflammation. Degenerative products of the inflamed tissue, that is the necrotic tissue or necrotic cell, dead cells. And then the complement complexes, these are derived by the immune responses by the inflamed tissues, and several reaction products of the plasma clotting and other substances also, which contributes in the inflammation, which we'll see in this next chapter, like histamine, heparin, serotonin. There are many more factors which will activate macrophages to go there and do the function of phagocytosis. Then what is a phagocytosis? Let's come here 1 minute. 100 micrometers and 50 micro. What is this? Is every cell in our body. This, let's say this is an chemotactic or the inflamed cell. Every cell in our body is not located more than 50 micrometers away from the capillary, but that's why it is easy for WBC to recognize those chemotactic substances and go there, go towards that inflamed cell by following that chemotactic substances. As stronger the chemotactic source or the concentration gradient of these chemotactic substances, the unidirectional the flow of WBCs means, like just say there are many particles here, that means WBC will be strongly stimulated that you have to come here only, but it is somewhere here, it is somewhere here, it is somewhere here, it's all dispersed. So will WBC might get diverted to somewhere other areas. So concentration gradient matters. Phagocytosis is a process in which the macrophages or neutrophils ingest the pathogen and digest it with the digestive enzymes, which are secreted by the lysozymes present in the uh, neutrophils and the macrophages. The but how the cell will decide that we have to kill that particular cell and we don't have to kill that particular cell? Because if these cells are going to attack tremendously in like there is an inflamed area, we need a rapid action. If they are going to act rapidly, they might damage our own body cells, and this is prevented by three selection barriers which are applicable on macrophages and neutrophil. In that first one, or the first selection process, is the smooth surfaces. Like if the surface smooth the surface is smooth in some certain areas of our body, the tissue surface or the surfaces are smooth, which causes in the motion hurdle in the motion of WBC's movement, and and in turn raises the phagocytosis, because like WBCs will move like crawl when they'll ingest and then again try to digest, they'll churn, but they won't be able to do because the surface below is the slippery or very smooth surface, but rough surface will increase the phagocytosis for sure. Second selection thing is the protective protein coats. This is the, I think, main one, because all of our body cells contains the protective coat, which tells the WBC that this is our own body cell and don't kill it, please. Because some dead cells obviously won't have the protective coat, and the foreign invaders, the bacteria won't have the protective coat. And if there is protective coat, these neutrophils and macrophages have certain enzymes, like polypeptide enzymes are there, and some lipases also there. We'll see in this later, which can easily degrade them. But in sometimes, in like bacteria like tuberculosis, bacilli, it is hard to digest them, and for that we have different mechanisms. Okay, coming to the main point, protective coats or the protective protein coats will repel the process of phagocytosis, but most dead tissues and bacterial cells won't have protective covering coats, so it is easy to phagocytize them. And then third is one of is one is related to the immune system. What happens in this barrier or this selection process is that antibodies produced by our body will bind to the infectious agent such as bacteria or any other kind of pathogen, and will adhere them will adhere to them and will make them susceptible, that bacteria, this antibody will make them susceptible for phagocytosis. And in that, when these antibodies gets attached to the C3 complement product of the C3 complement reactions, which we'll see next chapter. It is a product given by the immune produced in the immune response, and this C3 product will in turn attach to this membrane of phagocytic cell, that is the neutrophil or macrophages, as you can say, and initiate the response of phagocytosis. This process of selection is it's what contributes to the phagocytosis, and the destruction of these pathogens is known as the opsonization. Then, now, particularly talking about neutrophil, this was just an general overview how this cell perform. Now, particularly talking about the neutrophils, how neutrophil acts in our body and causes as the derives the function of phagocytosis. When a neutrophil approaches a particle that should be phagocytized, it projects a pseudopodia around the cell. Let's say what this is, and that bacteria. This is our neutrophil. It will go, it'll attach to this bacteria, then it will form its false pseudopodia by the movement of cytoplasm, and then it will entrap it, and then it will attach to itself, or it will attach its all boundaries and enclose this pathogen inside, and will make them it as a free floating body inside the cell, which is known as the phagocytic vesicle, or also called as the phagosome in the cytoplasm. In a lifespan of a neutrophil can kill about 3 to 20 microbia or the bacteria, and the neutrophil after that becomes inactive or dead, and this dead neutrophils will go to the pus formation, have next topic. Okay, then specifically talking about the macrophages. Now, macrophages and the neutrophil, their system of killing the bacteria is almost same, like ingesting it, then by the process of phagocytosis, then forming a free floating vesicle, then with the help of lysosomal digestive enzymes, it will lyse or destruct all these membranes of that cell, and remove the microbial debris by the process of exocytosis. But the difference in the macrophages and neutrophil is, neutrophils are already mature. They can attack rapidly and to the point at the same time they saw and they kill. But in the process of macrophages, as there are a low number of macrophages or monocyte inactive immature monocytes or immature macrophages are present in the blood, so it's hard for them to kill them. And another thing, or another difference, is that neutrophil can kill about 3 to 20 in the full lifespan, but macrophages are able to kill far larger size bacteria, which neutrophil can't do. And macrophages can kill about 100 bacteria in their lifespan, or as many at a time, also 100 bacteria at a time maybe. And after this, Macrophages can do the process of exocytosis and can still remain viable and do the function of phagocytosis for coming months. Then, once these all particles are phagocytized and digested by the intracellular enzymes, the neutrophil and macrophage will come in a contact with phagocytic vesicles, digested by the intracellular enzymes. Like when neutrophils and macrophages ingest all this pathogen, they'll form a free floating vesicle. This phagocytic vesicle combines with the lysozyme, which I explained earlier, and now they'll form a digestive vesicle. That means it contains microbes or bacteria with digesting enzyme, that is the digestive vesicle, and begins the function of digestion. And this digestive enzyme includes the proteolytic enzyme for the digesting of particular type of bacteria and other type of protein matter present in these pathogens. But there is a specific kind of enzyme, that is the lipases, which is only present in macrophages, lysosomes of macrophages. Keep in mind, proteolytic enzyme, both neutrophils and macrophages, but lipases only macrophages. Done? Yeah. Which will be used for destruction of lipid membranes of the bacteria, such as in the case of tuberculosis bacillus. But still, we are not that sufficient, or our macrophages are not that sufficient to kill this tuberculosis bacillus completely, and that's why they form a structure or a full balloon type of structure that we'll see in later. Not a structure, it is not there mentioned, but not fully mentioned, but it's mentioned, just mentioned. Okay. Neutrophils and macrophages can kill bacteria. Yeah, obviously they will kill bacteria and they are meant to kill bacteria. Neutrophil and macrophages contain bactericidal enzymes or the agents. You know, until now were talking about the digestive enzyme, which will help us to kill the microbia and the bacteria. But when these digestive enzymes are uh, unable to kill them or destroy them, then and there the bactericidal agents or the bactericidal enzymes come into play. And these bactericidal enzymes or the agents include the superoxides, hydrogen peroxide, hydroxyl ions. But these are the reactive oxygen species, if you remember from the biochemistry part. And there is a one lysosomal enzyme which is secreted by the macrophages and neutrophil both, that is the myeloperoxidase. What does myeloperoxidase do? It conducts or catalyzes the reaction between peroxide and the chloride, which makes a very very bad bactericidal agent, that is the hypochlorite. It is very dangerous for this bacteria. And all of these oxidizing agents are present in the phagosome, are present in the phagosome, or may be produced by, or they are produced by the special organelle in the neutrophils and macrophages, that is the peroxisome. Aside from that, some bacteria, like if you are taking name, that is the tuberculosis bacillus, they have a special coats which are resistant to the lysosomal digestion by any of the digestive enzyme or this killing agents, and they resist the digestion and digestive effect of the neutrophils and macrophages. And these bacteria are solely responsible for chronic diseases such as tuberculosis. Tuberculosis is not a deadly disease, but yeah, after some time it becomes a deadly disease. Monocyte macrophage cell system, which I mentioned earlier, now we'll go in little bit detail in this. That is also termed as reticuloendothelial system. And before we talked about the macrophages, which are mobile macrophages and which are capable of uh, uh, wandering or going in anywhere with the help of blood flow. But in this thing or this system, I'll just give you brief info about these uh, non-functional or the attached macrophages to the tissue, that is termed as the tissue macrophages. The monocytes, when enters the tissues, they get swollen, and then they become the tissue macrophages, and then this tissue macrophages can live for months and even years until they are called on for the specific phagocytic function. These macrophages are responsible for phagocytase of the large quantities of bacteria, viruses, necrotic tissue, and foreign invaders in the tissues. And with that, if these WBCs are stimulated appropriately, more of, not WBCs, monocyte or the macrophage cells stimulated appropriately, they can break their attachments with the tissues. As I said, there are two, not types of macrophages, but there are two macrophages. One is freely circulating in the blood, another is the attached to the tissues. But if we receive a proper stimulus for by the inflammatory tissues, then this bounded macrophages can break their attachments and form a fully functional macrophage, which is capable to kill as many as number of bacteria until the macrophage dies itself. Okay, and can respond to the chemotaxis. What is chemotaxis? That I already discussed. It is giving a response to the chemotactic substances produced by the inflammatory tissue. It is the chemotaxis. Then this combination of monocytes. Then what is a reticuloendothelial system? Here we just know about the, or we just remember our information, summarize whatever we have learned till now. But what the reticuloendothelial system consists of is the combination of monocyte, mobile macrophages, and fixed macrophages also, which we can uh, mobilize by the strong stimulus, and specialized endothelial cells in the bone marrow, spleen, and the lymph node is also considered in the reticuloendothelial system. Now, going one by one, how this reticuloendothelial system will act on this various types of tissues. Okay, but nowadays, instead of saying monocyte macrophage system or the reticuloendothelial system, in the previous era or the decades, we used to say it as monocyte macrophage system. Then it changed to the reticular endothelial system because it is mentioned in the medical literature. Mainly it's widely used as a reticular endothelial system, so it's just known as a reticular endothelial system. But nowadays the name has been changed again and is known as the MPS, mononuclear phagocytic system. As the function is the same, which can be summarized as they are the specific phagocytic system which are located in all tissues of our body, and these are in the large quantities where the inflammation or the toxin substances are present and needs to be phagocytized. Okay, then going by one tissues in our body. In that, first is the skin or subcutaneous thing of our skin. The skin is impregnable, means skin is almost not permeable to any kind of infectious agent in our subcutaneous tissues. But what if these pathogens enter in our tissue? Then the histocytes, that are the macrophages present in the subcutaneous layer, they gets activated and they form more copies of macrophages. They starts to divide in situ. What is mean by in situ? In situ means local division of macrophages or the local division of any kind of cell. That is the in situ production of macrophages, and they perform the usual function of attacking and destroying the infectious agent in that particular area with the full process of phagocytosis which we learned earlier. Then how about in the lymph nodes? In the lymph nodes, there is no way that particular bacteria or pathogen can enter directly into the capillary. How do they enter in the capillary? Is that, let's say this is an bacteria, it will first will enter into the lymphatic flow or the lymph flow. Then it will go to the lymph nodes which are present on the line or the uh, on what lymph flow or the full lymph flow system. There are lymph nodes, like this is the full lymph capillaries or the lymph flow, and there are nodes present which are known as the or called as the lymph nodes. And what this lymph node do? They do the function of phagocytosis, because the meshwork of the sinuses present in this lymph node contains the significant amount of tissue macrophages which are used for phagocytosis. Okay, and then what is this flow? We will describe here. I'll describe it here. Let's say this is our lymph flow going like this. Then lymphocytes, not lymphocytes, the pathogens will enter through these afferent lymphocytes, like from here, from anywhere, any afferent lymphatics. Then from this afferent lymphatics, they'll get trapped into this meshwork or this dense network of the sinuses present in the lymph nodes, which will cause the phagocytosis because this network is lined by the macrophages. And then after this destruction, they'll go to the efferent lymphatics, which is connected to the blood vessels or the venous supply, we can say venous blood supply. Then there's large number of macrophages are line in the lymph tissues that we know already. Then macrophages phagocytize them and prevent the general dissemination of these infections throughout the body. Then alveolar macrophages in the lungs, there is no specific name for this. Like there was specific like histocytes in the skin. There is no specific name in the lymphocytes. There's like macrophage only. In alveolar, it's the same. It's the another route. Alveoli is like through the respiration. It is the another famous route for inhaling bacteria or going them inside and getting trapped into the integral components of the alveolar walls, where the tissue macrophages are present in the large number. If these particles are digestible by the tissue macrophages, they'll digest them. But if they are not digestible, what they'll do, they'll form a giant capsule, which I told you earlier in the case of tuberculosis bacilli. They'll form a giant capsule around the pathogen. This giant capsule, let's say this is a tuberculosis bacillus, this is good example, it's good. This is a macrophage. It will attach and form a full globular structure or a giant capsule structure around this pathogen, and it will remain as it is until and unless this pathogen is able to dissolve or can be taken outside of the body. And this giant capsule formation will be done for the tuberculosis bacilli, silica dust particles, which causes the silicosis. These are also going to trap by the macrophages and form the giant capsule, and some carbon particles also in case of carbon monoxide, I think. Then macrophages or the Kupffer cell. This is just a name of macrophages in the liver sinusoids. Liver sinusoids. Here is the liver sinusoids are present. Macrophages or the Kupffer cells are present here. When this when this bacteria enters through this mucosa or the mucosal layer or the mucosal barrier of the GI tract from the ingested food and passes through the liver sinusoids, because our body passes blood first from GI tract, then to the liver, and then to the general circulation of the full body. When after ingestion of food, after ingesting these bacteria are penetrating our mucosal layer and going to the bloodstream, this bacteria will come to the liver. And when this blood or this blood capillaries disperse the blood throughout the liver, and when these microorganisms will be trapped by the macrophages, which are called as the Kupffer cell in the livers, will destroy them. And the Kupffer cells are very very precise in their function. They destroyed bacteria in 0.01 second. Okay, but what if these bacteria are not completely 100% destroyed in this Kupffer cell or the liver? Then in the general circulation, then this blood will absolutely will go to the general circulation means like every part of the body. But when this same blood goes to the bone marrow or the spleen, this spleen and the bone marrow have a meshwork or the reticular network of the macrophages. Like they are intertwined into each other. This it's a dense network of macrophages. As soon as this bacteria enters this network, they get phagocytized, they get killed. Specifically talking about the spleen, this is this part of a spleen or the structure of a spleen, we can say. Here one artery or the capillary is entering the spleen. Then when they enter, they form, or this artery entered in the spleen, they'll form the small capillaries on the red pulp of the spleen. There are two pulps, pulp and white pulp. Red pulp will have these capillaries, and these capillaries and the pulp membrane or the venous membranes or these venous sinuses and these capillary sinuses are lined by uh, tissue macrophages. And this there are vast number of macrophages, actually like very very large number of macrophages, because as all we know, Spleen is the organ which does the function of, or do the function of, phagocytosis of RBCs. It also takes the worn out or abnormal RBCs produced by the bone marrow and makes them inactive or kill them or destroy them in the spleen with the pathogens, obviously. Then inflammation is, in this inflammation there is a role of neutrophils and macrophages, a great role of macrophages. We have all known that there are lines of defenses in our body. We'll go one by one in this section. First of all, what is inflammation? Inflammation is the phenomenon which is caused by bacteria, trauma, or any chemical or heat or other phenomenon by any means. It causes the inflammation of tissue, and this tissue causes secondary changes in our surrounding uninjured tissues and gives out some tissue complexes, or this complex tissue changes is known as the inflammation, and there are some inflammatory products also. And these products, what these are the not products, this product, there are products like histamine, bradykinin, and all other. But how can we know that this is an inflammation or something like that? The characteristic of inflammation, we can see inflammation by naked eye. It's on the side or anywhere, like it will be on the skin only, or it will be morphologically visible only. But the characteristics of this inflammation are the first, vasodilation. If the vasodilation is there, that means there is an increased blood flow, increased permeability to the capillaries, which will allow the blood to go out in larger quantities, and which causes, or which have the more and more numbers of fibrinogen, which is a clotting factor. It causes increased clotting fluid in the interstitial spaces because of fibrinogen. Then migration of large number of granulocytes and monocyte into this inflamed tissue, and obviously the swelling of tissue, or the swelling of tissue cells around that area. And this, some of the many tissues produces reactions, and these reactions are histamine, bradykinin, serotonin, prostaglandins, and several other complement reaction substances, that is the reaction products of the blood clotting system. These are all the markers of the inflammation. Okay, multiple substances from the lymphokines that are released by the T cells, and that's it. Like, this all product what characterizes the inflammation, and these all are what we can know, and these are the products of inflammation. Then what is an walling off effect? As suggest is the name itself suggests, as a walling off means formation of a wall to protect other surrounding tissues. And this wall is formed by the fibrinogen. It is a clotting factor, and this wall is formed in the tissue surfaces and the lymphatic vessels to prevent the infection, and because of this walling up effect, barely a limited, a very low amount of fluid can flow through these spaces. That means barely any pathogen can enter our circulation. And let's say, for example, the intensity of inflammatory process is usually proportional to the degree. Means if the tissue injury is much more higher, let's take two examples, that is the staphylococci and streptococci. Staphylococci causes the rapid destruction or the rapid multiplication of themselves, or the rapid destruction of the surrounding tissue, and in response to that our body produces a rapid walling off effect, or stops or forms the wall of fibrinogen towards that inflamed tissue, so that inflammation or the invasion of these pathogens can be prevented. But in the case of streptococci, the streptococci is not that invasive, but later it becomes invasive for us. How? That streptococci is, firstly, it's not invasive, that doesn't cause rapid destructions of the surrounding tissue, so our body reacts like that. If the degree of reaction is low, the walling off effect will also be low. So low reaction of low destruction, that means low walling off effect. That what it causes, and gives times to that streptococci bacteria to multiply and disperse throughout our body. And this dispersed bacteria can cause a chronic inflammation, and which can lead to the death after several months or weeks if it is not treated well. Then macrophages and neutrophil response during the inflammation. And now I forget to tell you, that this oh sorry, I did okay. This is the first line of defense, not forget, this is the first line of defense, which is against the infection. Macrophage and neutrophil, uh, as I told you earlier, macrophage and neutrophil are the two components which carry out the main functions of phagocytosis or destructions of these pathogens and bacteria, by forming the lines of defense. In that first line of defense is the uh, macrophage itself. What does the macrophage do is that there is a macrophage present in the tissues. It, as soon as it gets to know that there is somewhere inflammation in our body, it increases in the size and shape, becomes larger and larger as much as it can possible, so it can ingest and digest much more amount of bacteria and pathogens. And second, it the function it do is the, I told you there are some macrophages present in the tissues which are bounded to the tissue membranes, which are called as tissue macrophages or inactive macrophages. After the inflammation, the first line of defense activate these sessile macrophages and turns into a mobile macrophages. Even though the number of mobile macrophages is low, but these mobile macrophages are always life saving for us. The sessile macrophages converts into the mobile macrophages. They enlarges into the shape so that kill more and more number of bacteria. These mobile macrophages are always life saving. This is summary. Neutrophil invasion of the inflamed area is the second line of defense. Why neutrophil is the second line of defense? When neutrophil causes a rapid destruction, they are matured enough in the in the circulatory system itself. Why it is secondary? Because macrophages are the one who are going to activate the tumor necrotic factor and the interleukin 1, which causes the invasion of neutrophils in the inflamed area. Means as soon as inflammation begins, the neutrophils will be rapidly transported to that inflamed area and invasion will occur. And this invasion is because of macrophage activated TNF, that is tumor necrosis factor, and interleukin 1. And these reactions are carried out, the further reactions that are carried out by the neutrophils are as follows. Like, they causes the expression of adhesion molecules strongly, which are selectins and ICAM1, that is intracellular adhesion molecule. These selectins, what they do, they are present, this selectin and ICAM1 both are present on the endothelial lining of the capillaries here, and they bind to the receptors which are present on the leukocytes, or we can specifically neutrophils. We are talking about the neutrophils. These neutrophilic receptors called as integrins, these integrins will bind to the selectin and ICAM1. In that, selectin will do the function of firm adhesion and cell migration from one location to another location. It like transport the neutrophil from locations to locations, and ICAM1 do the function of contracting them, squeezing them, and transporting them. It's like stuffing something inside. This is like, let's say this is an tissue space, this is an that ICAM, it will stuff this macrophage inside and go go to that and respond to that chemotactic substance which is secreted by the inflamed tissue. This is what happens. And this process of going this neutrophil towards the or out of the endothelial lining of the capillary is known as the margination. Margination, just remember what is margination. It is the going out of neutrophils from the endothelial lining of the capillaries in response to the inflammation, or in response to the chemotactic substances. Then what these macrophages can activated TNF and interleukin 1 can do, or these neutrophils can do, they can lose the surface of endothelial cells and the capillaries, which allows them to go faster enough, or which reduces their time to squeezing through the gaps or the little gaps of that endothelial lining of the capillary or the venules. By this process of diapedesis in the tissues, that's it. See, there are two differences which is just come here. Yeah, I'll come here only now. Then when this neutrophils comes out of that blood flow, they respond to the function of chemotactic. They respond to the products of the chemotactic substances and causes the chemotactic. They move toward that inflamed area. and this translocation through the capillaries to the tissues surrounding them is called as extravasation, and the specific passage of blood through the intact walls of capillaries is called as diapedesis. So the difference between the diapedesis and extravasation is that diapedesis is for all types of blood cells, and extravasation you can remember it as is particularly or specifically for the neutrophils. Okay, that's it. And because of this, all of this mechanism, within several hours will our body or that inflamed area will have enough number of neutrophils and macrophages which can combat that viruses or fight with that viruses. Then as the neutrophils are increasing in the number as they are coming here, that means the production of neutrophils should have been increased, and this is what a neutrophilia is. In the case of neutrophilia, how the neutrophilia happens is that our inflamed area or inflamed area will secrete some inflamed product. The inflamed product will travel to the bloodstream will go to the bone marrow, and there are some storages of the neutrophils, and this inflammation products will act on that storages and causes the release of that stored neutrophils in the free flowing blood, which increases the number or the count of neutrophils by 4 to 5 times. Like it was earlier 4 to 5,000, which is 62% of the total WBCs, but now it will become what, 15 to 25,000 per microliter. And after some time, when inflammation is reduced, the production of neutrophil will also be reduced. That's no problem for us. The neutrophil. So first line of defense macrophages, second line of defense neutrophils, now third line of defense is macrophages again. This macrophages, or this is where the third line of defense is explained, and the summary of this is here because it's like so much information and the summary is like this much only. The bone marrow and the circulating blood have low number of monocytes, which are the precursor cells of our macrophages. And even if these monocytes get transported to the tissues, and they'll still need days to become effective. At least when these monocytes are transported and reaches the tissue, at that time also they'll need at least 8 hours to become swell or be swollen and become a tissue macrophage, a fully functional full capacity tissue macrophage we can which can combat, which can fight with all types of all types of pathogens. So this third line of defense, we can say it as the cleaning the remaining bacteria or the bacteria which are coming newly, which are adding from the environment newly to the inflamed area. These macrophages have another function of initiation of antibody development, which will work with the lymphocytes and the antibodies, which will also act as the pathogen killer, which we'll learn in the next chapter. That's it. And then yeah, there is fourth line of defense also, which is given by, or which is formed by neutrophils, or more particularly saying granulocytes. Includes uh, neutrophils, basophils, and eosinophils, and macrophages also, or the monocytes also. What happens in the fourth line of defense is same as the third line of defense. They increase the number of production of the granulocytes and monocytes by the bone marrow, and this results in the stimulation of granulocytes and monocytic progenitor cells, and which produces them at exceedingly higher number. But still this process takes 3 to 4 days to make a new granulocytes and monocytes, and if the stimulus or the inflammation is continued for another 3 4 days, their production will be continued, and this production will be so higher that it can maximize up to 20 to 50% than that of the normal production of neutrophils, also granulocytes and monocytes. Then this production of granulocytes, monocytes, or macrophages is mediated by or controlled by some feedback control mechanisms. In that, the first one is the tumor necrotic factor TNF, which is used for neutrophil stimulation. Interleukin 1 used for neutrophil stimulation, Then GM, yes, CSF, GCSF, and MCSF. I have mentioned them here for your easier or for you to have it handy. TNF. TNF is a tumor necrotic factor. It acts on the neutrophil, activates them, and uh, forms the invasion or the many more numbers of neutrophils. Same in the case of IL-1. GM, CSF, GCSF, and MCSF are mainly for the production of granulocyte and monocyte. GMCSF is for granulocyte and monocyte. Keep eye on this first letter. If both of them means granulocyte, monocyte, colony stimulating factor. Then, if only one letter, that is G, that is granulocyte colony stimulating factor, and M is the monocyte colony stimulating factor. And this CSF combinations with the interleukin 1 and the TNF forms a strong feedback mechanism for the inflammation, where and which helps WBCs much more to remove the cause of inflammation. Then, as I mentioned earlier, that our dead neutrophils and some worn out necrotic tissues forms a pus. How the pus is formed and what is the pus? The pus contains the necrotic tissue, dead neutrophils, dead macrophages, and tissue fluids, and it is a mixture and which is known as pus. How the neutrophils are died, as you know, after the killing 3 to 20 bacteria, these neutrophils will die or become inactivated. These inactivated neutrophils, and then not most of them, but some of them, macrophages will also die in the process of phagocytosis. And this combining with the necrotic tissues, means dead tissues and dead cells of our body, will form the pus. And this pus will be autolyzed in our body in several days as soon as the inflammation is suppressed, and will be absorbed back in the tissues, and until the total inflamed area will be cured or the evidence of the damage is gone. Means if you have a cut or inflammation, until till the time it gets healed completely, this pus formation and absorption cycle will be continued. That's it. You know what? We are talking much more about lymphocytes and monocytes. That means like neutrophils and monocytes, macrophages, lymphocytes. But we are not talking about eosinophils and basophils, and they are crying in a corner. So let's just talk a little about them. So, eosinophils are about 2% of our blood, total blood volume. But these eosinophils are weak phagocytes, and which responds to the chemotaxis. That is also doubtful for us right now. But these eosinophils are present in a great number in peoples who are suffering from the parasitic infections that are too large. These eosinophils are smaller in shape, so they cannot engulf them. Then what they do, they attach to them, and they secrete some bactericidal substances, or the substances which can kill them completely. And these substances are hydrolytic enzyme from the granules, which are acts as their lysosomal enzymes. Then also by releasing the highly reactive forms of oxygen, which we discussed earlier, that is the superoxide, peroxide, and hydroxide, reduced form of hydroxide. These all are contains one extra pair of electron, or one extra electron, which is an reactive oxygen species for our body, and which very lethal or destructive for these pathogens or parasites. And also this eosinophil releases larvicidal polypeptide, which is called as the major basic protein, which kills the parasite in its larva form only. Let's take an example of schistosomiasis. Schistosomiasis is present in the 90%, 80 to 90% of peoples in the Africa, but it is also found in the Asia and South America also. And in the schistosomiasis, this eosinophil attached to the juvenile phase of this schistosomic pathogen, and kills them by secreting or releasing this all the substances like hydrolytic enzymes, then um, reactive oxygen species, and major basic proteins in the case of larva. Then another example of this eosinophil destruction, or the destruction caused by eosinophil, is the trichinosis. Trichinosis is a name of the condition, which is caused by trichonella parasite present in the pork, um, which we ingest or eat uncooked pork or infested pork, and they are present in that, means they are not completely killed while the process of cooking, and so they'll get in and they'll start infection, which will be combated or killed by eosinophils. That's it. And this eosinophil also have a special characteristics, that they want to go everywhere where there is an inflammation, like peribronchial tissues in the lungs and the skin after the allergic infections or the allergic reactions. And it is believed that this increased number of eosinophil is because of eosinophil chemotactic factor. Eosinophil chemotactic factor. This factor is secreted by the mast cell and the basophils into the free blood flow, which causes the eosinophil to go to the targeted tissue where the inflammation is present. It is also believed that this eosinophil can stop or detoxify the inflammation inducing substances which are secreted by the mast cell and basophils. And also believe that this eosinophil can destroy the allergen antibody complexes to prevent the spread of local inflammatory process, so that our body cells won't get harmed, the good body cells won't get harmed. Then next topic is the basophils. Basophils are very similar with the mast cell. Basophil are present in the circulating blood, and while the mast cells are present in the or outside of the capillary walls in the body. Both the mast cell and the basophil secrete some substances like heparin, which is an anticoagulant. Both mast cell and basophil also secrete histamine, small quantities of bradykinin, serotonin, and also substances, slow reacting substances of anaphylactic reactions, which are a group of three leukotrienes, some lysosomal enzymes. These substances causes a local vascular and tissue reactions, and this reaction mediate or they become a catalyst between them and mediate the allergic manifestation, so that uh, the appearance of allergic manifestation will be moderately present on outside. That's it. The summary of this passage is like basophils and the mast cells are similar, and they releases heparin, histamine, and low quantities of bradykinin, serotonin, and several lysosomal enzyme during the inflammation. And during the inflammation, mast cells are the only one who can secrete all these kind of substances and contribute to the inflammation. Both of these cell increases their secretion when this basophil or mast cell binds to the specific type of IgE antibody. When this mast cells or basophil binds to this IgE antibody, they'll increase their secretions of these substances, which again summarizing like histamine, bradykinin, heparin, anaphylactic substances, lysosomal enzymes, and which causes this mediation of allergic manifestation. Then conditions related to the WBCs or the white blood cells. There are two conditions: leukopenia and leukemia. Leukopenia is the low number of WBCs or the decreased number of WBCs in our body. Normally, our body lives in a condition called symbiosis, means our body lives with other kinds, some kinds of bacteria in our body. There are many other kinds of bacteria are present inside of our body. For example, like I'm talking now, there are many more bacteria like spirochetal bacteria, streptococcal bacteria, pneumococcal bacteria. They are going inside. Then I'm respiring like as you. There are some bacteria which goes through the respiratory tract. Also, there are some bacteria goes to the ingested food and get stored in the distal GI tract. In the, like for example, this bacteria called as the um, colon bacilli, which are present in the colon, that is the distal part of the gastrointestinal tract. There are other openings of the body like eyes, urethra, and vagina. From these roots, the bacteria can also enter. And there are so many routes, like there are freaking so many routes through which this bacteria can enter, and which causes the invasion of this bacteria, and which can cause us to become sick or which can destroy or start destroying our healthy tissues. And in this time, any number decreased in formation of WBCs, or the number of WBCs can lead to the higher or increased invasion of this bacteria. After the invasion, the bone marrow stops producing. If the bone marrow stops producing WBCs, new WBCs, within 2 days, our body will generate, or our body will show ulcers, mouth ulcers present here. It's like burning or little bit destroyed tissues here, or somewhere here in the mucosal lining of our mouth. And some ulcers can be present in colon also. Colon also, ulcers are very very deadly, and they are so bad. And they are along with this ulcer formation, they can form some respiratory infections also. And this from this ulcer, like, these ulcers are the exposed tissues, or the destroyed tissues, means they are the blood vessels, the lymphatic vessels are exposed to the uh, bacteria present in the environment, like welcoming, come come come. And it's like that. And this bacteria will enter through this capillaries, or these, more like saying ulcers, will enter through these ulcers in our body, causing the invasion and causing the destructions very rapidly of surrounding tissue of that ulcers or the infections. And if these conditions are not treated within an 1 week, not within an 1 week, if within an 1 week the patient might die because of untreatment or not getting a proper treatment due to acute leukopenia. Acute total leukopenia means there is no treatment, or there is a treatment. I'm not saying no treatment, there is a treatment, but this patient does not opt to get treated, then this can become a deadly for that patient. And some other cases, but it's very rare, these cases causes leukopenia in very very rare conditions. These cases are body's exposure to the x-rays, gamma rays, or some exposure to the drugs or chemicals like that, which contains benzene or anthracene nuclei, and is most likely to cause aplasia. Aplasia means the depletion of something, anything, depletion of anything, in this case the bone marrow. As all we know, x-rays or the MRIs, this causes of hitting radiation on our body causes the depletion of bone marrow. So getting x-ray or MRI continuously is also not good for our body. So this causes the depletion in bone marrow. Some drugs, that are drugs like chloramephenicol, which we take very commonly, which is an antibiotic. Then there is in thiouracil, which is used to treat thyrotoxicosis. There are even some various barbiturate hypnotics. These barbiturate hypnotics are used for the sedation purposes, for the sleeping purposes in some cases, but it's now kind of banned, but they are still available for the medical use for these sedations. And this is very unlikely or occasionally or rare that these substances will cause leukopenia. But after the moderate radiation will also cause the bone marrow degeneration, but our body will have enough number of hemocytoblast, myoblast, or the stem cells which can regenerate this lost bone marrow. And this while this regenerating process, patient should have time. Like, the patient shouldn't be like, oh, I'm dying now, and just give me now something so that I can survive. But this is not gonna work. That's what there should be time availability. And this, while this treatment, the doctors or the doctors, we should keep this patient on transfusion, antibiotics, some other drugs to kill the infections, and give that patient time, or that body the time to develop the new bone marrow in the body, which will regain its function of producing of normal red blood cells and white blood cells, some platelets, lymphocytes, everything. That's it. This was the leukopenia. Leukopenia, decreased production of WBC. Okay, causes X-rays, gamma rays, drugs like drugs like chloramiphenicol, drugs like thiouracil, barbiturate, hypnotics can cause this. Then, if not treated, ulcers can form, respiratory tract infections can form, If not treated within 1 week, patient will die. Okay. Then leukemias, it is also a deadly condition. Higher number of WBCs or lower number of WBCs, both of them are not good for us. So leukemias are the uncontrolled production of WBCs, which can be caused by the mutations of the myelogenous or lymphogenous cell. This is the leukemia, which is an uncontrolled production of WBCs. That's it. Then there are two types of leukemias. First one is lymphocytic leukemia, and second one is myelogenous leukemia. In the leukocytic leukemia, here I have highlighted, it is a cancerous production of the lymphoid cells, usually beginning in the lymph node. Means this are the benign type of cancerous production in the lymph node and other lymphatic tissues like spleen, liver, some other lymphogenous tissues where lymphocytes can be produced, and it destroys them and spread throughout the body, same as the myelogenous leukemia. Myelogenous leukemia is also gonna develop as a cancerous production in a young myelogenous cells, which will produced in the bone marrow and will spread throughout the other lymphogenous tissues throughout the body, which are spleen, lymph nodes, and livers. But in the not but also in the myelogenous leukemia, this cancerous cells production occasionally produces partially differentiated cells. There are three types of differentiation in the myelogenous leukemia. First one is the undifferentiated, partially differentiated, and fully differentiated. In undifferentiated, this is the undifferentiated. More the undifferentiated the cell, the more the acute leukemia, means more the faster it will be, and it will lead to the death within few months if not treated. Means all of these conditions are treatable, we can recover from them, but the treatment should be given or received. Okay. This is deadly. What? The undifferentiated one is deadly. Similarly, the partially differentiated cells, they are also at a certain point they become deadly, but because of partial differentiation, it forms types of leukemias in the myelogenous leukemia, that is the neutrophilic leukemia, eosinophilic leukemia, and basophilic leukemia or monocytic leukemia. In this condition of the partial differentiation, no cell or the this differentiated cell are not similar to any other kind of WBC, normal WBC. So it is very very difficult for us to recognize which cell is which and which leukemia is which type of leukemia, which is like neutrophilic or it is eosinophilic or it's basophilic or monocytic leukemia. It's very very bizarre condition, it's very messy condition. And in the complete differentiations of this cell, this generates a chronic inflammation, chronic disease, that is, and chronic increase of WBC's production in our body, which takes about 10 to 20 years in our body, and which results in the non-functional and failing to protect against the bacterial infection, kind of lymphocytes or leukocytes. Okay. Then effects of the leukemia on the body. The first effect of the leukemia on the body is the metastatic growth in the affected organ or the abnormal areas of the body. Means uh, abnormal area, we can say, like which is not forming well, or it's like little thing, or the we can say the meaning of that word is where the body is growing abnormally. There is the static growth, means a stagnant or slow growth of these cells in that region of the body. Then as there are increasing number, leukemia is the increased number of increased number of WBC, which causes the surrounding bone. These leukemias or the WBCs are mainly formed in the bone cell, that as all we know, which causes the surrounding bone digestion, which start digesting it or killing it, which causes the pain or eventually the tendency of bone fracture. Means they our bone becomes brittle over the time period. Almost all leukemia exhibit conditions called anemias and the uh, thrombocytopenia. Anemia. See, if in a single bone marrow or in any bone marrow in our body, if this bone marrow is producing a more and more number of increased number of WBCs, that means there is a decreased number of erythrocytes and platelets. How? In the reproduction or the formation of WBCs, we saw that there was a common hemocytoblast, from that myeloid, and then lymphoid. From that myeloid cell, there was types eosinophil base. Oh, sorry, uh, erythrocyte, leukocyte means precursor of white blood cell, and the megakaryocyte, precursor of platelets. If these WBCs are getting produced in larger number, means this cell is going to differentiate more and more in this kind of cells. That means there will be a decreased formation of erythrocyte and decreased formation of megakaryocyte, which will cause the thrombocytopenia, and this decreased production of RBC will cause the anemia. About all types of leukemia will spread throughout the body, including the spleen, node, lymph nodes, livers, other vascular regions, regardless whether this leukemia and originated a bone marrow or this lymph nodes. Yeah, and this will cause the, yeah, I told you already, this severe anemia and thrombocytopenia. What happens in the patients with this leukemia? The demand for the more and more food stuff, their body wants more and more energy, because this bone marrow or this body is producing rapid amount of WBCs. So more and more food stuff, more and more energy they are needing. That's why specific amino acid from our body and vitamins are taken by this you know uh, leukocytic cells, which forms these WBCs, and that is what causes the tissue degradation, means the deterioration of normal proteins in the tissues. It causes tissue depletion, and which results in the metabolic starvation, means our other body parts or other body muscles or tissues are not getting enough quantity of amino acids, proteins, or vitamins to synthesize and build up. That's why it causes the metabolic starvation. And if the metabolic starvation is prolonged for a longer time, then this will cause the death of that patient. So it is better to take precautions rather than taking medications and treatment. So stay safe, and guys, please, please, please like, share, and subscribe, means yes to L1, like, share, and subscribe, yes to L1, yes to. Thank you. Bye bye. See you in the next lecture, which will be on part 2 of this inflammation, and I might make a new lecture on WBCs from the biochemistry, so keep an eye on that. Thank you for your time. Thanks a lot. Bye bye. Bye bye.